Section 10.7, write and graph equations of circles. Let xy represent any point on a circle with a center at the origin. The origin, remember, is 0, 0. My pen is not working. So the origin 0, 0, and the radius is r. So that is a standard equation for a circle, where r is the radius, and notice there's no numbers there at all because it's at the origin, which is 0, 0. So when it's not at the origin, we actually have a center h comma k, which is x comma y, and the radius is still r. Let's see if we can make sense of that. Write an equation of the circle shown. The radius is 3, and the center is at the origin. So the center is 0, 0, and that is hk. So really it's x minus 0 squared plus y minus, sorry, that should be 0 equals r squared. Since h and k are 0, we're going to simplify that. And the radius is 3. 3 squared is 9. So we have our final answer. Write the standard equation for a circle with center 0, negative 9, and radius 4.2. So h is 0, k is negative 9, and the radius is 4.2. So let's square that radius. The radius squared is 17.64. So let's put it in our equation. X minus h squared plus y minus k squared equals 4.2 squared. Simplify. X squared plus y plus 9 squared equals 17.64. Okay, you try. Write the standard equation for a circle with a given center and radius. Push pause and try it on your own. There you go. You try again. Center negative 2, 5, radius 7. Push pause. There you go. Okay. The point negative 5, 6 is on a circle with a center negative 1, 3. Write the standard equation of the circle. There are two ways to do this because we need to figure out the radius. First, because this one's graphed, we're going to use Pythagorean theorem to figure it out. So I'm going to make a right triangle here. And count it. 1, 2, 3, 4. 1, 2, 3. And this is my hypotenuse. So 3 squared plus 4 squared equals c squared. 9 plus 16 is 25. C equals 5. So my radius of the circle is 5. It's the distance from the center to a point on the circle. So this one's easy. We can do x plus 5 squared plus y minus 6 squared equals 5 squared, which is 25. But if it was not graphed, we would use the distance formula. And there we just have the square root of x2 minus x1 squared plus y2 minus y1 squared. If I plug in what we have, negative 5 minus negative 1 squared plus 6 minus, 6 minus 3 squared, negative 4 squared plus 3 squared equals the square root of 25 equals 5. So if it's not graphed for you, I would just go for the distance formula. Okay, you try. There's the point and the center. We need to find the radius. Okay, the center, that's our HK, but you need to use the distance formula to find the radius so you can write your equation of the circle. Push pause. There's the answer. Push pause and check it out. Try another one. Okay, push pause. There you go. All right, let's graph a circle. The equation of a circle is given. Graph the circle. So we need to find out what the center is, HK. X minus 4, so that means H is 4. Y plus 2, which is really Y minus a negative 2. K is negative 2. 36 is the radius squared, so the radius is the square root of that, which is 6. So our center is 4, negative 2, and our radius is 6. Let's graph it. 1, 2, 3, 4, 1, 2. And the radius is 6. What I usually do is go from the center and just count 6 in all directions. 1, 2, 3, 4, 5, 6. That was poor planning on my part. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Once I've clearly drawn the radius out, I try to carefully draw a circle. Take your time, do your best. That looks okay. Next one. Okay, you tried. The equation of the circle is given. Graph the circle. So go ahead and find the center and the radius. Push pause. There we go. Okay, equation of circles given. Go ahead and graph the circle. If you notice, we are going by 3s on the graph because I couldn't get a bigger graph. That one was a bit messy, but you get the idea. Okay, we'll go over a few examples tomorrow. Here's the daily homework quiz. Page 1. Got 'em? Page 2. Okay, good luck.